On the next page, we're buying beef and other items at the store. Now, what is changing is the amount of beef we think we're going to buy. The dependent variable is going to be our total. Now, our other items are stagnant. They're not moving. We've bought a certain amount of items. We're kind of figuring out how much beef to buy. What we notice, if I add 1 pound of beef, I add $4, 2 pounds of beef, $4 more, 3 pounds of beef, $4 more. So my total is equal to 56. Why is it equal to 56 without the beef? Because there's no beef here, and we spent $56. We're going to add $4 per pound of beef as we move along. So we started at 56, and we're going to add $4 per pound. Discrete or continuous? Discrete are specific points. Continuous can be any number of points. We'll explain that as we go. The amount of money you make versus the number of iPhones you sell. You can't sell half an iPhone. So you've got to sell things like 1 iPhone, 2 iPhone, 3 iPhones. That's how many you can sell. That's what makes this discrete. You can't chop this up into an infinite number of pieces. There's specific points. The time it takes to complete a puzzle depends on how many pieces there are. Again, the number of pieces is going to be a whole number, a counting number. You can have 500-piece puzzles, you can have 1,000-piece puzzles. Again, a discrete function. The number of gallons depends on the number of miles you have driven. This one is going to be continuous. The reason you could drive 5 miles, you could drive 4.3 miles, you could drive 6.72519 miles. You can cut that up into infinitely small pieces and make calculations for the gallons based on that, and it still makes sense. So, continuous on this one. The height you are on a roller coaster depends on how much time you've been on. This one also is going to be continuous because you can be on it for 1 second, 1.25 seconds, 1.379 seconds. There's all kinds of ways you can cut that up, and it allows you to make that curve, as you go along. This graph would look like this because you're moving along the roller coaster. Whereas, the money and the puzzles, you would have specific points. This is a 500-piece puzzle. It's going to take you 1 hour. This is a 1,000-piece puzzle. It's going to take you 2 hours. Something like that. All right? It's got those specific points. Create your own discrete. For this one, really anything you choose as long as it's individual pieces, like the iPhone, the number of cars you wash at a car sale, how many cookies you sell at a bake sale, individual things that have to be kept whole. Continuous, how far you've gone versus, given a specific speed, but it can be cut up. This can be cut up into very small pieces, and it is going to be different person to person. Determine if it is a function or not, and then identify the domain and the range. Your domain, remember to use your set notation brackets. It's all the x values. I've got 1, 2, 1 is duplicated, and an 8. So 1, 2, and 8. You do not have to list the 1 twice. The range is our y value. We have 3, 5, -4, and +4. I like to list them in increasing order. You do not have to, depending on how your teacher is going to score you. But I will always put them in increasing order. Is it a function? No. Because if we have 1 for x, your y could be 3 or it could be -4. The fact that you have a choice makes it not a function. This one, your domain is going to be 4, 3, 7, and 10. Again, set notation brackets. Your range is going to be -4, 8, and 9. Now you'll notice that 9 repeats. We can have multiple y values paired, or the same y value paired with multiple x values, but each x value, if I want item number 4 on the menu, I want it to cost $9 each time. It doesn't matter if there's another item on that menu that also costs $9. Every time you get a hamburger, it's $9. Whereas in this case, you got a hamburger, you paid $3, you got a hamburger, they gave you $4 back. That's just weird, doesn't make sense, not a function. So this one is a yes. That one will be a function. Next one. Got a question mark on it. I'm going to fill that in. We're going down 2, or going up 2 rather. So that's going to be a positive one. Domain, our input is going to be 0, 1, 2, 3, and 4. Our range is going to be -7, -5, -3, -1, and +1. Function, yes, each x value has exactly one y value. This one should be arrowed. Domain is going to be positive and negative infinity. I'm going to write it like this. X can be bigger than negative infinity. It can also be smaller than, you know what, we're going to put dots on it. So I can give you a better one than that. X is going to stop right here at -4. We're going to go with dots. -4 is the smallest, the furthest to the left we can go. +4 is the furthest to the right we can go. And again, I'm assuming that these are going to be pointed. My range, it looks like I'm going 16, 2, 4, 16, 18. My range, same thing, -18 for y, and I can go all the way up to +18. It's a function because each x value has exactly one y value. Now, if you had arrows, you go positive to negative infinity. I'm going to use points so that we have, this is as low as my y goes. Even though the y heads down from right here, if I continue on, I still go up over there. This one, domain, I can be anywhere from -3. I'm going to stop this right here at +2. -3 to +2. All of those values are fine. My range is going to be right up here. I can be at, we'll call that +3. And I can go as low as, we'll guesstimate this at -1.5. Is it a function? No. Because example, at x equal -2, you have two choices for y. Since you have that choice, not a function. Function notation. Now in this one, domain, they're giving you an x value. They want to know the y value. So doing these, I've got f of -5. I'm going to take this equation. I'm going to put a -5 in for x. So I've got -35 plus 9. We'll get -26. In this one, I used function f. I put a -5 in for x. I got back a 36 in my equation. We'll go f of 0. I'll just put that one down. It's equal to 9. F of 1, you drop it in. 7 times 1 is 7, plus 9 is 16. And then my last one, f of 3. I've got 3 times 7 is 21, plus 9 is 30. And that's how we represent those answers. On 25, fill out the first one, g of -5. So I have 2 times -5 squared plus 5 times -5. This will be positive 25 times 2 is 50 minus 25. So g of -5 is 25. I use the function g. I put a -5 in for x. I got a 25 back. When I go g of 0, 2 times 0 is 0 plus 5 times 0 still 0. G of +1. I've got 2 times 1 is 2, plus 5 times 1, that'll give me a total of 7. And then g of 3. 3 squared is 9, times 2 is 18. 18 plus 15 is 33. Alright, moving right along. This one, I've got 3 functions. We'll cut this here.